Uh, so it says graph the function of this here. So what you need to do is you need to go modes, table function, setup. Quiet please. Now, I was frozen. What you do here, guys, you go to modes, you go to table function, and you enter in your formula. So in this case, it's just x cubed plus 4x squared plus 4x squared plus x, and then minus 6. Now, what I ask you for then is what is the start? The start is always the bottom value of the domain, which is minus 4. What is the end point? The end point is 2. Now, we're given a step is always 1 for the most part, and we're given a range of points. Let's see if these range of points match our graph. Okay, so you can see here minus 4 minus 10 is down here. You have minus 3, 0, which is here. You have minus 2, 0, which is here. And then you have minus 1, minus 4, which is located here. You have 0, minus 6, which is down here. And then finally, you have 1, 0, and final point being 220. 220 being all the way up here. This is your graph drawn. Now, some of you might have made the mistake of you might have went straight across or not high enough across. Can anybody suggest a way to find the middle point? Excuse me? The way to find the middle point is you go back to your graph. Everybody listening? Go back to your graph and you press everything the same, except this time you use a step of 0.5. This step of 0.5, what it'll do is it'll find you the point in between minus 3 and minus 2. The point in between minus 3 and minus 2 is minus 2.5. Minus 2.5 is roughly worth 0.9. 0.9 is just underneath the number 1. So you go roughly halfway up your line. So you can see halfway up your line and just barely underneath that, and that gives you your middle point. You go a bit further down and you can go back to see the minimum point of 0 minus 6. 0 minus 6 is grand, but you could also put in an extra point of minus 0.5, minus 5.6. So you can see that that extra point will be around there. And then the other point, which is 0.5 and minus 4.2, will be there. So you can draw in extra points to make your graph more usable, okay, easier to draw. Now, once most of you got this, okay, now we got to answer the question. Mick, can you pay attention to this? Find the values for which f of x equals 0. When does your curve equal 0? What points does your curve equal 0 on? Yeah, where it hits the x-axis. X equals minus 3, x equals minus 2, and x equals 1. Remember, it says where f of x equals 0. Go back to your calculator. This is the f of x section, isn't it? Look where f of x says 0. Just keep going up and down until you see zeros. Okay, so your first 0, sorry about that. Your first 0 happens here. X equals minus 3 is the first one. X equals minus 2 is the second time fx equals 0. And the third time it's equal to 0 is, there it is. X equals 1, f of x equals 0. So you can see our answers matches the table. Now, the next one is, guys, now look at this one. It's a really easy way of doing this. You looking, Paddy? See f of 1.4. Everybody see f of 1.4? What I could also do, once again, using my calculator, I could just go back in here, and this time, instead of, I'm going to use 0 to 2, and instead of using a gap of 0.5, what happens if I use a gap of 0.2? What happens now? Look at this, okay? It goes up in 0.2s. Is x equals 1.4 in this? X equals 1.4 is roughly the same as 6. Let's see if that happens on our graph. So go to x equals 1.4 on your graph. So where is x equals 1.4? 1.4 is just beneath 1.5. 1.5 is about here, which means 1.4 is just a tiny bit underneath it. Draw a line going up, and then draw a line going across, and you roughly get roughly 6. I probably went a bit too far to the right that time, so I'll go again. Let's try this again. Maybe it's a bit further to the right here. There you go. So the answer is 6. Everybody happy with that? When the input is 1.4, the output is 6. Estimate the local minimum and maximum values. What this means is your local min and local maximum values, not the points but the values, are the y values of the 2 points. So let me show you. Your maximum point is located where, guys? Your maximum point is x equals 2.5. What's the y value? It's underneath 1, isn't it? Because 1 is here. So it's just underneath the number 1. So call it roughly 0.9. Did we have this on calculator before? Does anybody remember? Did we actually have the maximum point on calculator? We actually did, because if you remember this, remember we did -4 to 3, and remember we did a step of 0.5. Look what happens. We know that the maximum turning point is, we know that that's when it's on its way up. So look at the 2.5 value. -2.5 is roughly worth how much? 0.9. This is the maximum turning point because it's on its way up. The minimum turning point is on its way down. That's your min, that's your max. Okay? So what I'm trying to tell you guys is that it's 0.9. So the maximum value, max value, is 0.9. Now what's the minimum value? The minimum value occurs where, guys? What point does the minimum value occur at?
0.
It's around -6, isn't it? 0 minus 6. So the minimum value is, minimum value is -6. Okay? Because that's the lowest point on the graph, is the minimum value. Oh, sorry, not the lowest point on the graph, but the lowest turning point on the graph is your minimum. Okay? Estimate the values of x for which f of x equals -2. When does your y value equal -2? So you're looking to find out what points on your graph does it have a y value of -2? Let's find out. So go to y equals -2. Y equals -2 is located where? This point here, isn't it? Go sideways. Alright? And then once you hit the graph, what do you have to do then? Go up, and then the other one, go up. Dennis, estimate what these values are. So estimate what this value is here. See it? -3 point what?
3.3.
3.3 is good. What about this one here? -1.5, I'd say. Probably halfway, isn't it? -1.5. And then the last one, which is located here. How much? Yeah, I'd go for... oh, sorry, I'm wrong. It's this one here. Yeah, you're right. It's 0.8. So, lads, there's your three values, isn't it? -3.3, -1.5, and 0.8. Let's look at the next question. Okay. Complete the graph as shown. Now, guys, can somebody give me the points we used? Does anybody have the points here?
Yeah.
Go for it. What is it?
-2, 0.
-2, 0. -111.
0, 4.
0, 4.
1
1
- 9.
minus 9.
2 - 16.
-16.
3 - 5.
So guys, what we can see is that the graph I drew here is roughly the same thing. -2, 0 is here. -111 is here. 0, 4 is there. What is it? 1 - 9. So 1 - 9 is, that's 1, and that is roughly -9, just above -10. Do you see that? Then the next one is, what's the other point? 2 - 16. Seems to be the minimum point, doesn't it? And then the last point, 3 - 5. Okay, 3 - 5. And then the last one is 3.511. 3.511 is roughly up there. 3.5 across and 11 up. Any questions on that? I'll pause it for a second. The next thing you guys are wondering is, you guys probably have a different looking graph to make. Now the reason for that is this. Because I'm using this program, to fit it in, I actually have to make the axis go up in 5s. While your graph, like Sam has shown me there, your graph will look a lot more pointy than mine. But it's still the same graph. It's like I'm zooming in. Okay? So your graph will look more like that, while my graph, I had to flatten it out to fit it in. Is that alright? Now, to do this, we're roughly doing the same thing, okay? Write down the coordinates. Now, coordinates, what does coordinates mean, lads? The word coordinates. means the x point and the y point for both of them. So what's the coordinates of the maximum? It's -1 and, anybody? 11, because we drew it on the graph, -1 and 11. What's the minimum? 2 minus 16 is the minimum, because that's the bottom turning point is the minimum, the upper turning point is the maximum. Now, write down, use your graph to find the values of x for which your graph is decreasing. And let me explain what a graph decreasing means. Always think of it like this, lads, alright? The way I remember this off is really easy. Increasing and decreasing. You always move left to right. Do you understand? You always start off on the left side of the board and you work your way as if you're hill walking to the right side of the board. So, at the moment you have to go uphill, don't you? That means it's increasing. Now, the minute you reach the top, x equals -1 at the top. Any point bigger than x minus 1, you're then going downhill. So you're decreasing. And you're walking downhill, and then when do you stop walking downhill? At x equals 2. So your answer is this. Your answer is, it starts at x equals -1, and it ends at, starts at x equals -1, ends at x equals 2. Now there's a maths way of saying this. You only start going downhill the minute you start walking away from x equals -1. Yeah? So -1 has to be smaller than your x value for going downhill. Because you're going downhill at -0.5, you're going downhill at x equals 0, you're going downhill at x equals 0.5, you're going downhill at x equals 1. Would you agree with that? I was going downhill. When does it end? 2. Less than 2. All the values in between x equals -1 and x equals 2, you're going downhill. Hence the function is decreasing. Alright? Estimate the values of x for which f of x equals 0. What does f of x equals 0 mean again? One thing, just to make sure we have the point. The answer for part 4 is -1 less than x less than 2. Okay? Now we're on to part 5. Find the values of x for which the y value equals 0. So what's the y value equals 0? -2, 0. Anybody want to take a guess at that one? What's halfway between 0 and 0.5? And it's just ever so slightly above halfway. So we go for 0.3. Alright, and then another one here. It's less than halfway between 3 and 3.5. 3.2. So what are your three values for x for which the y value is 0? X equals -2, x equals 0.3, and x equals 3.2. There are your three values. Sam, get off the phone, please. Now, question 5. Draw this function. Once again, same trick as always. You put it into the calculator as x cubed minus 4x squared. Okay, and then you have your +5 at the end. Just 1 second, sorry about that. So you have your +5 at the end. Okay, you start at -2 because it says -2 on the question, and you end at 4. Because here's what I need you to be step of 1 for the time being. Now, is everybody agreed that these points here are the same points that are on my graph here? So -219, I simply couldn't fit it in. But you understand that it's on its way down to -219. The point I could fit in was -10, which is here. I could fit in 0.5, which is the maximum, which is here. I could fit in 1.2, which is here. I could fit in 2 minus 3, which is there. And then 3 minus 4, which is the, sorry, what's that? 3, oh wait. Everybody can see that the minimum isn't 3 minus 4, is it? So some of you might have had a graph like this. Was it 2 minus 3 and 3 minus 4? So you would have had 2 minus 3, and you would have done it like this: 2 minus 3, 3 minus 4. Some of you might have turned like this, and then went really, who did that? Turned really sharply like that. Now, how do you stop yourself from making that mistake in a test? So you go back to your calculator, and instead of using a step of 1, you're going to use a step of 0.5, like so. 1 second, Dennis. The step of 0.5 will give you some new points to draw. So let me show you the new points you're going to draw once it loads it up. Okay, so go down to your turning point, because your turning point is the problem. Okay, so we'll start off with the first turning point. The first turning point has a point of minus, isn't it? It's minus a half and minus a half and 3.9. So look at this. Minus a half is around here. 3.9 is here. So that's minus a half, 3.9 is roughly there. Draw another point. Plus a half and 4.125. So plus a half. So 4.1 roughly there. So you see our 2 points are relatively level. Okay. Then we're going to go down to the other turning point, which seemed to give us a bit of bother. The other turning point has the point 2 minus 3, which is here. Next do 2.5. 2.5 minus 4.4. So 2.5 is here. Minus 4.4 is around there. And that gives us another turning point. You see that? Okay. And then we have the point 3. So by doing it this way, you can see that some of you might have drawn it like this. But that's a bit closer to what you would have had otherwise. Do you get that? Draw in the extra point. Then, you the question.
Yeah, you know how I do pointy sometimes?
There was some people, and this is quite common anytime you mark leaving cert, some people draw a turning point like this. And what I'm saying is, if you do that, you're losing marks. It's a curve. Okay, just remember that. It's a curve. You can't really draw this one like this either. You have to sort of draw like a curve. Okay. Now that we have that done, what we're going to do next, guys, is estimate the values for x for which f of x equals 0. When does f of x equal 0, lads? When is the y value worth 0? That's what the question means. What point is the y value worth 0? Well, minus 1, 0 for a start, yeah? The next point, 1.30. The point after that, 3.70. They're the three answers, the values of x. So you need to do the values of x. So x equals minus 1. X equals, what's x equal to? 1.3. And x equals 3.7. Now lads, the next one's a trick question, right? If you ask you this in your leaving cert, it's going to be a really tough question. It's going to be a part C. And it's for anybody particularly looking to get over a B. Okay? So let me explain how this works. See this equation here? It's completely random. You haven't used that equation yet, have you? Does it look like any equation we've already used? What equation does it look a lot like? It looks a lot like the one we started with. So write the one we started with underneath. Now, how would you change the one we started with to the one that we're currently using? Take away 3. So break up the 5. Are you listening? Break up the 5 into 2 plus 3. Do you understand? I broke up the 5 into 2 plus 3. Yeah. Now, I'm going to move the 3 over the other side. Now, this is very random. You'd never know how to do this unless you've done a couple of them. Does everybody agree with what I did there? I broke up the equation we used into, see the way that had a 2. I broke up into 2 plus 3. If this said 1, I'd break it into 1 plus 4. I'll do another one in a second for you too. No, not yet. Now guys, what is this the same as? It's the same as g of x. It's the y value of the function. Do you understand? So the output of the function must equal minus 3. Where does the output of the function equal minus 3? You go to minus 3, you go straight across, and you come back up again. What are the x values?
2 and 1.
So the x values are minus 1.2. The other one is 2. And the last one? 3.3. Let me give you another one, because I guarantee you none of you have a clue what that's about. Okay, let me try another one with you, okay? If I made up the question to look like this, I'm going to make up the question to look completely different this time, alright? Instead of x cubed, I'm always going to use x cubed, and I'm always going to use 4x squared. Instead of using 2, This time I'm going to use 3. Okay, so just get rid of all this for a second. So this time, instead of using 2, I'm going to use 3. So you're asked to solve this equation. Okay, x cubed minus 4x squared plus 3. It looks like nothing you've used already today. Is everybody happy with that? Now, I'm going to compare it to the formula I've used. This full drawn is a drawn of this here. What is the difference between the red one and the black one? Instead of a 5, we have a 3. So what I'm suggesting we do is that we change the 5 into 3 plus 2 this time. And then to make it really look like that one, I should move the 2 to the other side. And it looks like this here. Minus 2. Everybody happy with that?
Yeah.
Now once you've done that, what is this exactly the same as? Oh, wait. Oh, sorry, excuse me, guys. My bad. Sorry. I'll do this again. Sorry, my fault. Sorry. What we want is this here, right? Yeah? Now, what we have is this. That's our drawn, yeah? Now, I'm going to modify this drawn to look like this. Is x cubed minus 4x squared plus 5 minus 2. What's plus 5 minus 2 the same as? The 3. When I bring the 2 over the other side, I'm going to get x cubed minus 4x squared plus 5 equals 2. What is this the same as? That's the same as the graph. Therefore, the graph's value must equal 2. Go up here, the graph value equals 2, and then go straight down. I actually did the first one wrong, so I'll redo these. So what are the x values? Anybody tell me? Minus 0.9, 1, and the other one? 3.6. Okay, let me try this. That's the 3 answers. Let me try this again one more time. Now, I'm going to be honest, lads, 90% of the population ain't going to get this question done in the Leaving Cert. Okay, that's the way it goes every year. But look, we'll just say we did it anyway.
Does it come up every year?
No, very rare, but so I wouldn't be getting too worried about it. Once again, guys, this one here, I don't use that one. The one I use, the one I've drawn, is this one here. So how do I turn the one I drew into the one I actually have? So look at this, guys. Ready? X cubed minus 4x squared plus 5. Now, lads, what do I need to take away from 5 to make 2? 3. Bring the 3 over the other side. X cubed minus 4x squared plus 5 equals 3. The graph I drew needs to be the same value as 3. So I'll go up to 3, and then I'll go straight down, and this is the answer to the question I'm being asked. Minus 0.7 for the first one, yeah. Second one is going to be 0.8, and the third one 3.8, 3.9. Okay. Sorry about that, lads. That one is confusing. Okay. I'll do one more of these now. Like all your other questions, you've drawn out your graph. You've drawn out a graph of a curve, and you've drawn out a graph of the line. Okay, guys. G of x, which I'm covering in red, g of x is the red line. So I'll just make sure it's colored in red for a minute. So g of x is this line here. Everybody alright with that? G of x being that one there. Now, g of x is the red line, and the black curve, the black one is the curve. Okay, how would you get the points for both of these, lads? How would you get the points for this? Put them into the calculator and draw them out. So just so I'm not going too fast, you can put it into g of x. You can put g of x into the calculator as 9 minus 3x. Okay, once you've done that, you're going to have to start at minus 2, and you're going to end at 4. Okay, and once you've done that, you draw your points. look very closely. The point minus 215. I haven't got them all drawn, so I'll show you the ones I do have drawn. I have the point minus 112. See minus 112? Located here. And see the last point, which is going to be roughly 30. 30 is located here. And 4 minus 3 is just out of the graph's view. Is that right? Then the other graph you're going to draw is you're going to draw this one here, which is your x cubed. Just get rid of this for a second. You're going to draw your x cubed, so alpha x cubed minus 3x squared. Okay, then you're going to draw minus 4x, and then you're going to draw plus 12. Okay, once again, starts at minus 2, ends at 4 as shown, and you're just going to draw these points here. So you can see from the graph we have minus 20 is here, isn't it? We have minus 112. Now, minus 112 and 012 are 2 points, but because they go straight across, what does that mean? It means the turning point has to be exactly in the middle. And how would we figure that out? Anybody tell me? You've done it a couple of times today. I'd put the step as 0.5, and I would know that I'm looking for minus a half. So go to minus a half on your calculator, and you get 13.1. So just 13.1 roughly. Okay, so you should know roughly to go up to 13.1. And what I'm basically trying to get at is that in your leaving circles, you don't even need to guess. You can just basically just put it into your calculator and find out exactly where it's meant to be. There's absolutely no need to guess, okay? Especially when you're using a Casio. Once that's done, guys, you just draw out the rest of the graph. When you draw out the rest of the graph, you got to answer some questions on it now. So let's try and answer some of the questions that we're being given here. Okay, so the question we're being given is, when is f of x equal to 0? When does which one's f, guys? Is the curve or the line? F is the curve, and g of x is the line. When does the curves? This question means when does the output of the curve equal 0? I.e., when does its y value equal 0? So Paddy, when does its y value equal 0 for the curve? It's on the board if you want. The y value of the curve equals 0. When does the y value of the black line equal 0? Yeah. Minus 2, 0. So x equals minus 2 is one of them. When's the next one? X equals 2 is the second one. And then finally the third one? X equals 3. Everybody see that? When does the y value of the curve equal 0? Next one. When does the y value of the curve equal 12? Go to 12 and draw a line going straight across. I'll draw a different coloured line. Black one here. Dotted line. Okay, go across y equals 12, and when you hit the curve, what do you need to do? Minus 1, 0, and 4. The answer is minus 1. So for part 2, that's part 1. For part 2, your x values are minus 1, 0, and 4. Perfect, lads. Right? Part 3. What does part 3 mean? When does the output for the curve equal the output of the... What's G, guys? Line. When does the curve equal the line? When does the curve equal the line according to the graph, lads? You tell me. Sorry?
When does it touch the line?
When did the intersect is basically the question.
12 and 6.
And what are the x values? Do you want the x values? It does.
3. 3 is the x.
So x values are x equals 3. There's another 2 values. This one here. X equals 1. And the other value? X equals minus 1. There's your 3 values right there. Is that alright?
Do you have to write out y on it?
And now, if you read the question, find the values of x.
Oh, okay.
So the question specifically says the values of x. So you don't have to write down the x values.
Yeah.
Now, when is your curve bigger than your line? Anybody recognize when is your curve bigger than your line? Let's start off, okay? At -2, it's easy to see that the curve is below the line. Do you see that? Now, when are they equal to each other? When are they equal to each other? They're equal to each other at, I'll just write this down. So we're doing part 4 now, guys. When is, basically it's asking me, when is the curve, because f of x is the curve, when is the curve bigger than the line? Well, we know they're equal at x equals -1. And when are they equal again?
3.
X equals 1. And following that, they're also equal at x equals 3. Now let's check this out, guys. Curve has to be bigger than the line. At x equals -1, they're the same. But what happens immediately after that? The person on the curve is higher than the person on the line. So it starts at x equals -1. It continues until when? They both meet each other back down here, don't they? It's just a way of thinking of it. And it ends at greater than equals here, sorry. So it ends at x equals 1. Okay? Now, opposite to that question is the next question. When is the curve smaller than the line? Curve smaller than the line? Anybody tell me? When it goes under it. So at the start and until -1. So any x value smaller than -1, you're talking about the guy on the curve is going to be beneath the guy on the line. Then at the very end of the question, which is here, the guy on the when is the curve smaller than the line? Oh yeah, in between here and here, isn't it? So when is the curve smaller than the line? It's any value smaller than -1. But look at here, guys. The guy on the line is up here, yet the guy on the curve is down here. So it starts at 1 and it ends at 3. For your homework tonight, guys, you're going to be doing all the questions from 3 to 6. They'll be on video to help you out later on.